I will start with the live session for structure, form and energy, the synergy. Today we will be doing week 7, assignment 7. Um, so this is an NPTEL course and the course instructor for this course is Professor Shubhajit Sadhu Khan. And I am Shreya Shukla. I am the NPTEL course TA for this course for only live sessions specifically where we solve previous year questions. Today is the 7th session and today we will be doing the previous year questions of week 7. So without any further ado, I will start with the session. So what is this course about? So the four terms that are used in the title of the course are structure, form, architecture and synergy. So what all these terms mean? Structure. In architecture, structure means it refers to the system which is used to support and transmit possible loads on the building to the ground. It gives stability and it resists stresses and strains. What is a form? In architecture, a form is a three-dimensional object or building that is perceived by a viewer in space and time and made possible by the action of light and shadow. What is architecture? Architecture is the art and technique of designing and building. What is synergy? Synergy means the interaction or cooperation of two or more organizations or agents which produce a combined effect greater than the sum of their separate effects. So today we will be doing the previous year questions of the week 7. This is a total 8-week course and this is the second last session. So the syllabus covered in week 7 included 5 lectures, structure and architectural forms in windy areas, structure and architectural forms in seismic prone areas, structure and architectural forms in flood prone areas, cost effective structure and architecture, structure and light in architecture. Question number 1. Any wind that has a perpendicular component to the line or direction of travel is referred as seasonal wind, prevailing wind, local wind or crosswind. So the question is asking that the wind that has a perpendicular component to the line or direction of travel. So I'll quickly define all the 4 terms for you. So what is wind? Wind can be described as the movement of air from the high pressure area to the low pressure area. It is an air movement having both direction and speed. It is made up of gusts and eddies that can only be felt and not seen, unlike rain and snow. Prevailing wind or permanent wind. Prevailing wind is also called permanent wind and they are winds that blow from a single direction over a specific area of the earth. Areas where prevailing winds meet are called convergence zones. Generally, prevailing winds blow from east to west rather than north to south. Seasonal wind. Seasonal wind is the wind that change their direction with onset of different seasons. They are hence called as seasonal winds. Seasonal winds are movement of air repetitively and predictably driven by changes in large-scale weather patterns. Seasonal winds occur in many locations throughout the world. A monsoon is a type of seasonal wind in low latitude climates that seasonally changes direction between winter and summer. Monsoon is prevalent in India. Local wind. Local winds occur due to the movement of air between high and low pressure systems within small areas. As there are different types of winds, each one is slightly different from the other. Local winds always have a significant effect on climate in particular regions, and these blow only during a particular period of the day or year in a small area. For example, land and sea breeze. Crosswind. Crosswind is any wind that has a perpendicular component to the line or direction of travel. This affects the aerodynamics of many forms of transport. Moving non-parallel to the wind's direction creates a crosswind component on the object and thus increasing the apparent wind on the object. Such use of crosswind travel is used to advantage by sailing craft. On the other side, crosswind moves the path of vehicles sideways and can be hazardous. So the answer is crosswind. Any wind that has perpendicular component to the line or direction of travel is actually called a crosswind. Question number 2. Arrange the following building shapes responsible for creating a high to low pressure of wind. A, B, so these three shapes are given, in which A is a circle with a corner edge, B is a shape with a lot of edges, and C is a rectangle with curved edges. So according to the NPTEL lectures, this diagram was given in one of the lectures, in which it shows that these three shapes, which one has more pressure. So circle has the least pressure, then a cube or a square has pressure. Eddies are created on both the surfaces of the square, and then a building with multiple edges has more pressure. So if we go by this diagram, then A will have the least pressure and C will have more pressure than A, and B will have the most pressure. So the question was asked that you are supposed to arrange this from high to low pressure, which means the highest pressure will be on B, then C, and then A. So our option will, so the correct answer will be B, B, C, A. So B shape will have most pressure of wind, C will have less pressure than B shape, and A will have even less pressure than C shape. So the correct answer is B. Question number 3. Dash refers to one level of building. Dash refers to one level of a building that is significantly more flexible or weak in lateral load resistance than the stories above it. Soft story, clear story, multi-story, hard story. So the question is asking that what refers to one level of a building that is significantly more flexible or weak in lateral load resistance than the stories above it. So I'll explain the terms quickly. Soft story. The term soft story refers to one level of a building that is significantly more flexible or weak in lateral load resistance than the stories above it and the floors or the foundation below it. 70% or greater reduction from one floor to the next according to the Modern International Building Code (IBC) definition. Clear story. In architecture, a clear story or clear story uh, or overstory is a high section of wall that contains windows above eye level. Its purpose is to admit light, fresh air, or both. Then multi-story basically means that it's a building which has several forms at different levels above the ground level. So the answer is soft story. So what is soft story? Soft story basically means that one level of a building or one story of a building is significantly more flexible or weak in lateral load resistance than the other stories above it. Question number 4. Richter scale is used to measure the dash intensity: tsunami, earthquake, flood, and wind pressure. So Richter scale is also called Richter magnitude scale, Richter's magnitude scale, and Gutenberg Richter scale. It is a measure of the strength of earthquakes, and it was developed by Charles Francis Richter, and it was presented in his 1935 paper where he called it the magnitude scale, which was later revised and renamed the local magnitude scale, denoted as ML. So Richter scale is basically based on a formula on the amplitude of the largest wave recorded on a specific type of seismometer and the distance between the earthquake and the seismometer. The So that scale was specific to California earthquakes and crust, and other scales based on wave amplitudes and total earthquake duration were developed for use in other situations, and they were designed to be consistent with Richter scale. So this is how a Richter scale looks like, in which one side has Richter magnitude and the other side has the frequency written on it. So um, the seismograph shows the amplitude of seismic waves, and it records the amplitude of seismic waves, and it's covered in it's basically turns out as a like a polygraph, the image. And then you see this image that I have added over here. It basically shows that different major earthquakes that have happened throughout the world and throughout the years, and where they locate on the Richter scale compared to. So this, for example, the Alaska earthquake had a Richter scale of 9.2, which has great significance, and it lies way above on it. So this graph basically has been covered in colors showing how severe the earthquake was. So some of the earthquakes with their Richter scales have been marked over here, with San Francisco earthquake having 7.9 Richter scale and California earthquake having 6.9 Richter scale, etc. So Richter scale is basically used to measure the earthquake intensity. Question number 5. Which of the following brick bonds has cavity in it? Flemish bond, zigzag garden bond, English bond, or rat trap bond? So Flemish bond, or the plural Flemish bonds, it's an arrangement of bricks such that each course of brick consists alternate bricks having their short sides, which are called headers, and long sides, which are called stretchers, facing outwards with alternate courses being offset. So what happens in Flemish bond is that one header, the brick is laid in such that you can see in front one header, and then one stretcher, and then one header again. So that's how the Flemish bond is laid, and the subsequent layers are also like that. One header, one stretcher, one header, one stretcher. So a Flemish bond pattern consists of each course of alternate headers and stretchers. The patterns arrange such that every header is centrally supported over the stretcher below it. The facing and backing of the wall have the same appearance in Flemish bond. So I've also added the image of the courses in Flemish bond. So for example, first course and second course I have added. So that's how it is laid. One brick is laid in such a position that in front you will have the header. Then two bricks are laid in which the stretcher will be in the front, and that's how it is laid. And then when we put a course above the first course, we put a divider on it, or you can say an additional brick with a half brick size, which basically shifts the next layer a little, and such that the all the headers are centrally supported over the stretchers below them, if you see the pattern. Then English bond. So in Flemish bond, what happens that in each course there is alternate of header and stretcher, but in English bond there is one layer of stretcher in front, and then one layer of headers in front, and then again one layer of stretcher in front. So it's alternate this way. So it contains courses of stretchers, side of bricks alternating with the courses of headers, ends of bricks throughout a wall surface. An English bond can be constructed for almost all wall thicknesses. This bond is the strongest among all other bonds. No continuous vertical joints are formed, and in the elevation, the alternate course either shows headers or stretchers. Every header is an alternative course, comes centrally over the joint formed by the two stretchers below it. Then zigzag bond. A zigzag bond is a bond in which the bricks are laid in a zigzag pattern throughout the joint. The herringbone and zigzag bonds are example of same type of bond. It is used for paving works in residential constructions such as floors, footpaths, because of the attractive appearance of this bond. Then rat trap bond. Rat trap bond is a modular type of masonry bond in which the bricks are placed in a vertical position which creates a cavity in the wall while maintaining the same wall thickness as that of the conventional brick masonry wall. It is also known as the Chinese brick bond, and the purpose of using this type of masonry bond is to reduce the number of bricks and mortar required compared to the English and Flemish bond, and because of the cavity that is formed in the wall. Architect Laurie Baker introduced it in Kerala in 1970s, and it is used extensively for its lower construction cost, reduced material requirement, and better thermal efficiency, which happens because of the canopy that is created between this bond, than other kind of conventional masonry walls, without compromising the strength of the wall. So this is how a rat trap bond looks like, in which this cavity happens because it is laid out like this, that the cavity is created, which makes this bond cost effective and also thermally better. So our answer is rat trap bond. So amongst the options that have been given, rat trap bond is the bond that has cavity in it. Question number 6. Dash is a low wall built at the side of a river to prevent it from flooding. Crown, levee, mount, or peak. So the answer is levee, because other terms are not related to the flooding term. So I will explain what is levee. So a levee or dike, embankment, flood bank, or stop bank, it is a structure that is usually earthen and that often runs parallel to the course of a river in its floodplain or along low-lying coastlines. The purpose of a levee is to keep the course of rivers from changing and to protect against flooding of the area adjoining the river or the coast. Levees can be naturally occurring ridge structures that form next to the bank of a river, or they can be artificially constructed fill or uh, wall that regulates water levels. However, levees can be bad for the environment. Ancient civilizations like Indus Valley, ancient Egypt, Mesopotamia, and China all built levees. So what happens in levee is that a river is going, and so that the river does not flood the plain right next to it, or it doesn't change course. So a levee, which is like a mound, is built around it so that the width of the river is restricted. It does not flood the adjacent plain, or it doesn't change its course also. So levees can also be naturally occurring, but they are often made man-made to help avoid flooding. And levees as a construction technique, as a technique to save from flooding, has been used in ancient civilizations, even in like Indus Valley, Egypt, Mesopotamia, and China. So this is how a levee looks like. So this is how a levee looks like. Uh, this is some examples of levees that I have added here. So the answer is levee. Levee is a low wall built at the side of a river to prevent it from flooding. Question number 7. Which of the following is not a seismic wave? S wave, love wave, sigma wave, relief wave. So S waves, which are also known as secondary waves, shear waves, or shaking waves, they are transfer waves that travel slower than P waves. In this case, particle motion is perpendicular to the direction of wave propagation, and for example, the S wave, basically what happens in S wave is that the direction of wave propagation is in this direction, imagine, but the motion of the particles would be on the up direction, which causes the wave to go like this. So that's why it's like a slinky. And the example of an S wave, here it has been given of a slinky, and slinky is that coiled thing that comes, which you stretch and pull back. So if you stretch one slinky and you leave it, so that slinky actually goes this way. So it creates a transverse wave, and that creates a S wave on it. Love wave in seismology, seismology is the study of earthquakes. Love waves are surface seismic waves that cause horizontal shifting of the earth during an earthquake. Augustus Edward Hugh Love predicted the existence of love waves mathematically in 1911. They form a distinct class, different from other type of seismic waves such as P waves and S waves and Rayleigh waves. Love waves travel with a lower velocity than P or S waves, but they are faster than Rayleigh waves. These waves are observed only when there is a low velocity layer overlying a high velocity layer or sublayers. So what happens in love wave is that uh, they are seismic waves which basically cause a little horizontal shifting of the earth during the earthquake. And then what is Rayleigh wave? A Rayleigh wave rolls along the ground with a more complex motion than love waves. Although Rayleigh waves appear to roll like waves on an ocean, the particle motion is opposite to ocean waves. Because it rolls, it moves the ground up and down and forward and backward in the direction that the wave is moving. So in Rayleigh waves, basically particles actually move in rolls, because of which the earth goes up and down, forward and backward, and in the direction that the wave is also moving. So the major type of waves, seismic waves, can be classified into two categories: surface waves and body waves. Surface waves are love waves and Rayleigh waves, which basically are visible on the surface of the earth. And then body waves, P wave and S wave. So our answer here will be sigma wave. So which of the following is not a seismic wave? Sigma wave is not a kind of seismic wave. 8. The glass used in the City of Arts and Sciences in Valencia is mainly for filtering daylight, obstructing daylight, minimizing daylight, or absorbing daylight. So, so this is image of one of the structures in the Center of Arts and Sciences in Valencia. It is basic. It's the Center of Arts and Science in Valencia is in Spain. Um, most of the buildings here were designed by Santiago Calatrava. It's actually a cultural and architectural complex in the city of Valencia. And it is the most important tourist destination in the city of Valencia, and it is one of the 12 treasures of Spain. The construction cost of the entire complex is is actually 1200 million euros, and the architect was Santiago Calatrava for 6 buildings. There are 7 buildings in the complex. In one building, the oceanographic was designed by Felix Candela. So there are 7 buildings in this complex: Le Hemispheric, Museo de les Sciences, Prince Philip, Le Umbracal, Le Oceanographic, Palau de Arts, Reina Sofia, Montevillet Bridge, and Assault de Lor Bridge, and La Gura. So this is a panoramic view of the structure. So what is filtered sunlight? So filtered sunlight is basically direct sunlight that fills the room most of the day, but it is filtered by either curtains, blinds, annoying, even trees which are right outside the window, or sometimes glasses which are specially made for that purpose. These are some of the images of the interior of the buildings of located in the center of arts and sciences in Valencia. So these are some of the images of these buildings. So you can see how the light is coming through in these buildings because of the structure that has been given. Just a second, my laptop is. Two more examples. And again, all these examples are from the interiors of the buildings located, all the 7 buildings that I have mentioned in the Center of Arts and Sciences in Valencia. So you can see how well lit and how filtered light is coming in all these buildings from outside. So the answer is filtering light. So the glass that has been used in the City of Arts and Sciences is to filter the daylight. It is not to obstruct the daylight, it is not to minimize the daylight or absorb the daylight, but it is to filter the daylight so that the daylight does not directly come in harshly, but it is filtered, which only lights up the room and not is very harsh. Question number 9. Which of the following structural bracing system is shown in the image below? Diagonal bracing, K bracing, chevron bracing, or V bracing? So this image has been provided in which a building is shown, and along with the structure you can see that some bracing has been provided, and then you are being asked that what kind of bracing is this. So I'll quickly go through with it. So diagonal bracing is a structural component of just about any building. It provides lateral stability and it prevents the collapse of walls, decks, roofs, and many other structural elements. In diagonal bracing, basically top end of the structure and bottom end of the structure are joined diagonal. So that's how diagonal bracing comes. Then K bracing. K braces connect to the columns at mid height. So this frame has more flexibility for the provision of openings in the facade, and it results in the least bending in floor beams. K-bracing is generally discouraged in seismic regions because of the potential for column failure if the compression brace buckles. So what happens in K-bracing, the last image that I have added is actually K-bracing, that in the center of the column, in the K-braces, the brace is connected at the center of the column, not bottom and but not bottom or top, but the center of column. So it is really good if you want to provide large openings in the buildings. It's really good for that, but it is avoided in seismic regions. Then chevron bracing. Chevron bracing is basically the opposite of V bracing. So chevron brace steel frames, also known as inverted V brace frame (IVBF), is a concentrically braced frame configuration commonly used in practice. Primarily resisting the load with truss action, the IVBF provides very high lateral elastic stiffness and strength. So if V bracing is in the shape of V, that the top of the beam is attached to the middle of the slab, and then this top of the beam is attached to the middle of the slab. Then chevron bracing is opposite to that, which means that the joint between the column and the slab is attached to the top of the ceiling. V bracing, two diagonal members forming a V shape extend downwards from the top two corners of a horizontal member and meet at the center point of the lower horizontal member. Inverted V bracing, also known as chevron bracing, involves two members meeting at the center point on the upper horizontal member. So this is chevron bracing, because you can see it's inverted V first of all, and secondly it is coming from the top horizontal member, which could be a slab, to the down below. So this is actually chevron pattern. This pattern is called chevron pattern, which is from where the term chevron bracing is coming. Question number 10. The following illustration is an example of strike slip fault, normal fault, reverse fault, longitudinal fault. So what is fault? A fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly. So it's basically a fracture or zone of fractures between two blocks of rock. It allows the blocks to move relative to each other, and this movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep. Faults may range in length from few millimeters to thousands of kilometers. Strike slip faults. Strike slip faults are vertical or nearly vertical fractures where the blocks have mostly moved horizontally. So the fracture is vertical. So there are two blocks of rock. So the fracture is vertical, and because of this vertical fracture, the movement is horizontal. So basically, if the fracture is vertical, the movement is horizontal in strike slip faults. The cause of strike-slip fault earthquakes is done due to the movement of two plates against one another and the release of built-up strain. As the larger plates are pushed or pulled in different directions, they build up strain against the adjacent plate until it finally fails. Normal fault. So a normal fault or a dip-slip fault is in which the block above the fault has moved downward relative to the block below. Block below the fault. This fault motion is caused by extensional forces and results in extension. Other names are normal slip fault, tension fault, or gravity fault. So in normal fault, one of the rocks moves up and the other moves relatively to the down dock below the fault. Reverse fault. The opposite of normal fault is a reverse fault, where the rocks on the uphill side of an inclined fault plane rises above the rocks on the other side. Reverse faults often form along convergent plane boundaries. In a reverse fault, the block above the fault moves up relative to the block below the fault. This fault motion is caused by compressional forces and results in shortening. A reverse fault is called a thrust fault if the dip of the fault plane is small. So what happens in normal fault is that so there are two blocks and there is this fault which is, let's say it's inclined fault. The block which is already above the fault, it moves a little down to the block which is below the fault. So in normal fault already one of the block is a little above, but it comes down. What happens in reverse fault, that the block which is already up is above the fault goes more up, so the distance increases more. Longitudinal fault, it's a geological fault with its strike parallel to that of the regional structure. A fault whose strike is parallel with that of the general structural trend of the region is longitudinal fault. So the example shown here is of strike slip fault, because the fault is vertical and the movement, because the arrow is there and the movement is in the horizontal direction, so it's a strike slip fault in this image. Question number 11. Which of the following is not a type of storm? Tornado, hurricane, derecho, or tsunami? What's a storm? A storm is a generic term which is popularly used to describe a large variety of atmospheric disturbances, which ranges from ordinary rain showers and snowstorms to thunderstorms, wind and wind-related disturbances such as tornadoes, tropical cyclones, sandstorms. In meteorological terminology, storm is restricted to a cyclone along with a low pressure center, strong winds ranging from 103 to 117 kilometers per hour, accompanied by heavy precipitation and at times lightning and thunder. What's a tornado? A tornado is a violently rotating column of air extending from base of thunderstorm down to the ground. Tornadoes are capable of completely destroying well-made structures, uprooting trees, hurling objects through the air like deadly missiles. Tornadoes can occur at any time of the day or night and at any time of the year. Hurricane. Hurricanes are known as tropical cyclones. They are low pressure systems with organized thunderstorm activity. They gain their energy from warm ocean waters, and as storm system strengthens into hurricanes, the surface wind move continuously in a circular motion, and the direction of circulation is different depending on where the storm is located. It is counterclockwise in the northern hemisphere and it's clockwise in the southern hemisphere. Derecho. Derecho is a widespread, long-lived straight-line windstorm that is associated with a fast-moving group of severe thunderstorms known as a mesoscale connective system. Derechos can cause The earthquakes can cause hurricane and tornado force winds, heavy rains, flash floods. Tsunamis. Tsunamis are giant waves caused by earthquakes or volcanic eruptions under the sea. Out in the depth of the ocean, tsunami waves do not dramatically increase in height, but as the waves travel inland, they build up to higher and higher heights as the depth of the ocean decreases. So our answer is tsunami. So tsunami is actually not a storm, but tsunami is basically they are giant waves. They are not storms. They are giant waves which are basically caused by earthquake under the sea, earthquake or volcanic eruptions under the sea. So they are not storms, but they are giant waves. So tsunami is not a type of storm. Question number 12. The following photographs is the construction of a options are given: hollow slab, coffer slab, filler slab, precast slab. So this image has been given and you are asked to identify like what kind of slab is this the picture of construction of. So quickly going off over the examples. So excuse me. Hollow slabs or hollow core slabs, they are pre-stressed floor products with either round or shaped voids, round or oval shaped voids, depending on local requirements. They are one of the most popular, efficient, and long span floor construction components that exist today. Coffered slab, coffered slab structure with reinforced ribs in the lower zone, which have mutually perpendicular arrangement. Ribs between the coffers are reinforced, creating concrete beams spanning two waves to support the slab. The coffer slab is ideal for longer span slabs carrying heavier loads. Filler slab is an alternate slab construction technology where part of concrete in bottom of slab is replaced by a filler material. The basic principle of this is that the concrete in bottom half of RCC slab is structurally not required as concrete acts as a compression material which is required only in the top half portion of slab. So this portion concrete is replaced by low cost lightweight filler material like mangrove tiles, clay pots, etc. Precast concrete. Precast concrete is a construction product produced by casting wet concrete in a reusable mold or form, which is then cured into a controlled environment, transported to site and installed in place. So in hollow slabs what happens is that they are pre-stressed floor products and they have voids in them. In coffer slab they can be made on-site and off-site both. And in coffer slab the coffers are created which are basically cubes you can say, or a grid you can say. They are grids in which the grids of beams, heavy beams in both ways, which creates a waffle-like structure. It's also called a waffle slab, is created. In filler slab, so the concrete in the bottom part of RCC slab does not have a structural significance. So to reduce the construction cost, a lightweight filler material is filled in this. And yeah, so lightweight filler material is filled in this, which could be clay pots or mangrove tiles, etc. So our answer is filler slab. This is an image of a filler slab being constructed, where you can see that the steel has been laid out and the basic concrete level has been filled in the framework, and then the pots are being put in to create the filler material, and then the concrete will be poured over it. Question number 13. Which of the following forms is supposed to perform the best against heavy wind? Circle, square, rectangle, or hexagon? So again repeating from the question in the starting. So the circle has the least wind pressure, Then square has more wind pressure than circle because eddies are created on the surfaces both side of the square, and then any shape with multiple edges will have more wind pressure because eddies are created in all those corners. So our options, again coming back to the question, that which of the following forms is supposed to perform the best against heavy wind? So, like as shown, as seen in this image, that the circular shape has the least wind pressure created over it. So, that's why it is most suitable for heavy windy areas, because the eddies are not created and then the pressure is not created, rather the wind goes around the circular shape and travels. So, our answer would be A, circle. Question number 14. Uh, the following illustration is an example of strike slip fault, normal fault, reverse fault, or longitudinal fault. So as I explained in the previous question, a fault is a fracture or zone of fractures between two blocks of rock. Faults allow blocks to move relative to each other, and this movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep, and the faults can reach from a few millimeters to thousands of kilometers also. So I explained strike slip faults in the previous question also, that in strike slip faults the fractures are vertical and the movement that is caused is horizontal, and in normal fault a fault is there, and the block which is already above the fault moves down relative to the block that is already below the fault. So, and in reverse fault, uh, the block the block which is already above the fault moves more above the fault. So the answer here is reverse fault, because as you see that one block is above the other, and we see the direction is of the arrow is in the upwards direction, which makes this diagram for reverse fault and not normal fault. In normal fault, the portion, the block above the fault will have the arrow downwards. So this is an image of reverse fault. Question number 15. Which of the following is not a seismic wave? P wave, Q wave, Rayleigh wave, or S wave? So I explained this also in the previous question, that S waves are known as secondary waves or shaking waves or shear waves, and they are transverse waves that travel slower than P waves. And what is P wave? P wave was not explained in the previous question. So what is P wave? It is also known as primary wave or pressure wave, and it travels at the greatest velocity through Earth. When they travel through air, they take the form of sound waves. Because of their speed, they are the first waves to be recorded by a seismograph during an earthquake. They differ from S waves in that they propagate through a material by alternatively compressing and expanding the medium, where particle motion is parallel to the direction of wave propagation. This is rather like a slinky that is partially stretched and laid flat, and its coils are compressed at one end and then released. So what happens in P waves is that whichever material the P waves travel through, it compresses the material and expands the material or the particles, you can say, along its traverse. So the material, the motion, basically the material, or you can say the particle, the motion of the particle is moving along the direction of the wave. So it compacts and expands, compacts and expands. In S wave, however, the motion of the wave is like this, but the motion of particle is like this. So it's on the perpendicular direction to the wave propagation. So the particle moves up and down, up and down. The wave is moving like this, but the particle is moving up and down, up and down. That's how P wave and S wave are there. Then Rayleigh wave and love wave, they were also explained in the previous question, that in Rayleigh wave, The particle motion is actually roll, and these are called surface waves, and the entire surface moves like this as the particle moves. And in love waves, horizontal shifting of the earth occurs in this. So the answer is Q wave. Q wave is not a seismic wave. Seismic waves are P wave, S wave, Rayleigh wave, and love wave. Question 16. Levee is found instrumental for protection against fire, flood, earthquake, or landslide. So as I explained in the previous question again, that levee uh, is actually a wall, a mound you can say, which is built along the bank of a river to restrict the width of the river, to avoid the flooding of the plain right next to the river, or to not to help the so not to help so that the river does not change the direction. So our answer is flood. Levee is a constructional technique, or it's a construction technique which is used for protection against flood. Question number 17. In most of the airport terminals, space frame with glass cladding is used to maximize daylight usage, ensuring long span space, provide view to external environment, all of the above. So, yeah, space frames, open structural forms like trusses, space frames, mega structural openings, and even areas where structural members are normally connected, they all admit light inside the structure. In architecture and structural engineering, a space frame or space structure, 3D truss, it is a rigid, lightweight truss-like structure constructed from interlocking struts in geometric pattern, specifically mostly in the shape of tetrahedron. They can be used in they can be used to span large areas with few interior supports. Space frame structures are mainly used in buildings that span large areas with few interior supports. They are also used because of their pleasing architecture. Space frame architecture can be found in airports, stadiums, exhibition halls, swimming pools, and towers. The cost of transportation is less as compared to conventional steel structures. Space frame or space structure also allows odd placement of columns along the integral cladding and glazing. Therefore, modularity is achieved with these structures. It is efficient both structurally and functionally, and they also allow hassle-free erection and a geometric balance, and they boost the aesthetics of the construction and offer flexibility. And it is also easily expandable and are built following assembly line approaches with a very minimum amount of seismic resistance. They also provide good daylight and view of what's out too. Here are some examples of space frame structures. So the answer is all of the above. In most of the airport terminals, the space frame with glass cladding is used to, it is used to maximize daylight usage. It is used to ensure long open spaces, because we need long open spaces in specifically in areas like airports where a lot of crowd is continuously moving. C, provide view to external environment. So the answer is all of the above. Question 18, which is I think the last question of today's session. AAC block in building construction refers as autoclaved aerated concrete, added admixture concrete, advanced annular concrete, added alkaline concrete. So AAC block is actually called autoclaved aerated concrete. It is made with fine aggregates, cement, and an expansion agent, which causes the fresh mixture to rise like a bread dough. This type of concrete contains 80% air, and in the factory where it is made, the material is molded and cut into precisely dimensioned units. Cured blocks or panels of autoclaved aerated concrete are joined with thin bed mortar, and the components can be used for walls, floors, and roofs. The lightweight material offers excellent sound and thermal insulation, And like all cement-based materials, it is strong and fire resistant. In order to be durable, AAC requires some type of applied finish such as polymer modified stucco, natural or manufactured stone or siding. The weight of AAC block is about 80% less than traditional red bricks, and it leads to a reduction in the use of cement and steel. Thus, it saves cost. Moreover, being environmental friendly, AAC blocks ensures better durability and improved sound and heat insulation compared to bricks. So, the full form of AAC blocks, which is used in building construction, is autoclaved aerated concrete. So, that's all for today. This was all about the uh, week 7. We are left with one more session, and there is a possibility that Professor Shubhajit himself might join us for the last session. So, yeah. So, if anybody has any doubts, please kindly ask. You can type it in the chat box. I would answer it best to my capacity and knowledge. In case I will not be able to answer your question, I would do it in the next class uh, after reading more about it and discussing with the uh, professor whose course this is. So, in case anybody has any questions, kindly let me know. You can type it in the chat box. Okay. If you don't have any questions, I would wait in the session in case somebody else joins and I would answer their question. So if you don't have any more questions, you can leave the session.